Hi folks, Mr. Long here. I'm going to do some factoring of some perfect squares. And I guess the first thing we have to recognize is what is a perfect square. And a perfect square really is, because I don't know how much more perfect can a square really be, right? So algebraically a perfect square is when you end up with, you can see this is x plus 3 by x plus 3, and what we end up with is x times x is x squared, x times 3 is 3x's, and then because it's a square, the length and width is the same, that's going to be 3x's, and the last one is going to be 3 times 3, which is plus 9. So it's always going to have a perfect square at the start for the variable, the x square. It's always going to have a perfect square for the constant, and then the middle term is always going to be double of the product of the two terms in the factor. Anyway, let's take a look at that. We've done it in class, and we've used the formula. So what we're going to do here is square the first term, x squared. Now this is expanding. Then we're going to go 2 multiplied by 3 multiplied by x. 2 times 3 is 6. 6 times x is 6x. And then we square the last term. 3 times 3, or 3 squared, is 9. That's how we square things. Okay, let's check this one when a is not equal to 1. So first thing I do is I square that. Well, what is that squared? The most common thing people will write is 3x squared. But you have to square the 3 as well. 3 squared is 9, x squared is x squared. So that's 9x squared. Then what we have to do is double, take 2 of the product of these. So double of negative 4 times 3x. So 2 times negative 4 is negative 8. Negative 8 times 3 is 24x's. And then I square the last term. Negative 4 times negative 4, or negative 4 squared, is positive 16. So what's our strategy for going in the other direction? Okay, so that was called expanding. Now what I want to do is I want to go in this direction. Okay, I'm going to take the standard form and put it into factored form. Well, the strategy that we can use for that is this. Check that the first term and the third terms are squares. So here, x squared and 9 are both square numbers. Square root of x squared is x, square root of 9 is 3. Then we have to make sure that the second term is double of a times b. So in this case, 6x would have to be double of, the square root of 9 is 3, square root of x squared is x. What's the double of 3 times x? Well, 3 times x times 2 is 6x. And then finally, you put it in factored form. Okay, folks, so let's try some examples. So here's our first example, number 1. f of x is x squared plus 12x plus 36. So does it have this form? By the way, f of x is just another way of saying y equals. So a squared plus 2ab plus b squared. Does it have that form? Well, a is going to be equal to x. B is going to be square root of 36, which is 6. And then 2ab equals 2 times 6 is 12. 12x's. Did I do it right? Yeah, that's definitely a perfect square. So now the solution to that is, we know a squared plus 2ab plus b squared equals a plus b squared. So in our case, we know that a is x and b is 6. So it's just going to be, the a value is x plus 6 all squared. Okay, and that's what y would equal. Now to solve that is actually quite easy. If I wanted to get the x-intercepts, I would have 0 equals x plus 6 squared. X would equal negative 6. Okay, x would equal negative 6. And there's only one solution. So it's just the vertex is sitting right on the x-axis. Okay, let's try another. This would be number 2. Okay, 9x squared minus 6x plus 1. So again, does it have the form a squared plus 2ab plus b squared, which is the perfect square? Well, square root of 9x squared is 3x. That's a. Square root of 1 is 1, and that's b. So that's a, that's b. The middle term should be 2ab. And what does that equal? 2 times 1 is 2, times 3x is 6x. Ah, but there's a minus, so it has to be minus 6x. That's fine. So if it's minus 6x there, I know that it's going to be 3x minus 1. Okay? So instead of 3x plus 1, this will be 3x minus 1. So minus or plus works. I just have to pick the correct sign. And since that right there is a minus, then I'm going to have to pick a minus there, right? It's going to have to be minus 1. Okay, so it works. I've got double a times b. So let's go ahead and write that. So a plus b squared will then equal, a is 3x, but now it's a minus because I have a minus in between, minus 1. And that's squared. Okay, so I could go 0 equals 3x minus 1 squared, and x would equal 1/3. Okay, add 1, divide by 3. So there's a single x-intercept again, and it's right on, the vertex is right on the x-axis. Okay, so again, you can watch these, slow them down, speed them up, you know, look at them a couple times, look in a different resource online if you want to. There's many different ways to do this. Okay, let's check and see if this one is a perfect square. First thing I do, I check that one. Yeah, 25 is a perfect square. 25x, square root of 25x squared is 5x. Square root of 4 is 2. So that looks like A, that looks like B. So what is 2AB? 2AB is worth 2 times 5x times 2. 2 times 5 is 10. 20x. Well, take a look at that. I've got 20x here, but only 10x here. So can this be a perfect square? No. Not a perfect square. Okay, so if you're done this, you're ready for the third set in that list of, in that handout on factoring and solving for x-intercepts.